Intermediate Algebra for Statistics, Factoring Out the GCF. Lesson objectives: factor out the greatest common factor, GCF, of a polynomial. Factor polynomials completely. Lesson objective: Example 1. Factor number 1, 10x squared minus 15x. Number 2, 8x cubed plus 20x squared. Solution: our first step is to look at these two terms and ask, are there any common factors in this term and in this term? So if we look at the numbers 10 and 15, we know that 5 is a factor of 10 and 5 is also a factor of 15. If we look at the variables, we have x squared, which is x times x, and we have an x, so x is a common factor. So 10x squared is the same thing as 5x times 2x minus, again, 5x times 3 is the same thing as 15x. So that means we can factor out a 5x. So this is just like the distributive property backwards. We pull the greatest common factor outside the parentheses, and what goes in the parentheses is the remaining factors that's left. So here we have a 2x left for this term, and we have a 3 left for this term. Number 2, again, we want to look at the factors in this term and see if there's any common factors. So we have the factors of 8 are 1, 2, 4, and 8. Any factors of 20 share those? Well, 8's not a factor of 20, but 4 is. So 4 will go into 20, and 4 will divide into 8. If we look at the variables, we have x cubed, which is x times x times x, and we have an x squared, which is x times x. So therefore, we have a factor of an x times an x, because it's here and it's also in this term. So think of this as just like the distributive property going backwards. What is 8x cubed divided by 4x squared? Well, the answer is 2x. So this term times this term gives me this term. Now if I take 20x squared and divide it by 4x squared, I'm left with 5. So the 4x squared is the greatest common factor for these two terms. Now pulling this away, so next we take our greatest common factor, write it outside the parentheses, and then we write what's left over inside the parentheses. Now there is a way we can check this. We can use the distributive property here, and we should get this answer back. So let's do that. So to check, we're going to take our 5x and distribute, and we should get the original problem for number 1. So 5x times 2x is 10x squared, minus 5x times 3 is minus 15x, so it checks. Number 2, we multiply 4x squared times 2x squared plus 4x squared times 5. We should get our original problem, and we do. 8x cubed plus 20x squared, so it checks. Greatest common factor definition: the greatest common factor, GCF for short, of two or more terms is a monomial with the largest coefficient and the highest degree that is a factor of all the terms. Let's do another example. Example 2. Factor 18x to the fourth minus 30x squared. We begin by looking at both terms, and we want to factor each of these terms to see what is the greatest common factor. So 18x to the fourth factors to 2 times 3 times 3 times x times x times x times x. So if you did a factor tree on 18, you would get these three factors. X to the fourth means a base of x times itself 4 times. 30x squared factors to 2 times 3 times 5, and x squared is x times x. So what's in blue are factors in both terms. This will be our greatest common factor, 6x squared. So we are doing the distributive property backwards, so we're dividing each term by 6x squared. 18x to the fourth divided by 6x squared is 3x squared, minus 6x squared divided by 30x squared is 5. So we pull out the 6x squared, and what we have in parentheses is 3x squared minus 5. We can verify this work on a graphing calculator. In y1 we put the original binomial, and in y2 we put the expression 6x squared times the quantity 3x squared minus 5. Next we hit second and graph, which is table, and we see y1 is equivalent to y2. The answer has been verified. Example 3. Factor 14p to the fourth t plus 21p squared t squared minus 70pt. Solution. We first find the factors of all three terms. So 14p to the fourth t becomes this. 21p squared t squared is this. And 70pt becomes this. So if we look at the numbers, we see 7 is a factor in all three terms. So is p, and so is t. So the common factor 7pt will be our greatest common factor. So we divide each term by the greatest common factor, and we are left with 2p cubed plus 3pt minus 10. If we wanted to check this, we can use the distributive property. So multiply each term by 7pt, and we should end up with the original polynomial. Less objective. Example 4. Factor 3x cubed plus 21x squared plus 36x. Our first step is we want to find the greatest common factor for all three terms. So if we listed out the factors, we would see that the greatest common factor is 3x. So factoring out a 3x to all three terms gives us x squared plus 7x plus 12. Now the next step is, does this trinomial factor? And if you recall in previous videos, what two factors multiply to give me a positive 12 and at the same time add up to give me a positive 7? Since c is positive and b is positive, both terms should be positive, and it turns out that if we list the factors 3 plus 4 equals 7, and 3 times 4 equals 12. So this is the value of c, this is the value of b, so it does factor. So our final answer would be 3x times the quantity x plus 3 times the quantity x plus 4. So that polynomial factored into a monomial times a binomial times another binomial. Leading coefficient is not 1. This means when the value of a is not equal to 1. Rule. When the leading coefficient of a polynomial is positive and the greatest common factor is not 1, first factor out the greatest common factor. Factoring out the opposite of the greatest common factor of a polynomial. Process. When the leading coefficient of a polynomial is negative, first factor out the opposite of the greatest common factor. Let's do an example. Example 5. Factor negative 2r to the fourth plus 18r cubed minus 40r squared. Now in this case, our a is not equal to 1, and it's also negative. So in this case, a is a negative 2. We will factor out the opposite of the greatest common factor. Solution. If we look at each coefficient of all three terms, we see that 2 is a factor for all three. And if we look at the variables, we have r to the fourth, r cubed, and r squared. This power is the smallest, so that means that we can take out an r squared here, an r squared here, and an r squared here. So that means we can factor out a negative 2 here, a negative 2 here, and a negative 2 here. And we can also factor out an r squared, an r squared, and an r squared. So we will pull out a negative 2r squared from each term. When we do this, the signs of each term will change. This is negative, now it's positive. This is positive, now it's negative. And this is negative, and now it's positive. Now if you're unsure, you can always do the distributive property and verify that your answer is correct. Our next step is to see if this trinomial inside the parentheses will factor. So is there two factors that multiply to give me 20 that add up to give me negative 9? Now because C is positive and B is negative, both the signs will be negative. So what two numbers multiply to give me 20 and add up to give me a negative 9? Well, if we take negative 4 times negative 5, that's a positive 20, and negative 4 plus a negative 5 is a negative 9. So our factors become r minus 5 and r minus 4, and then we times that by our greatest common factor. So our final answer is negative 2r squared times the quantity r minus 5 times the quantity r minus 4. To verify this using the graphing calculator, we type in our original problem in y1, and y2 we type in our answer, and we use our table feature to see that they are equivalent. So it checks. Thanks for watching.